Assalamualaikum warahmatullahi wabarakatuh and a very good morning. In this video, you are going to learn about Chapter 7 Analysis of Variance, or we call it as ANOVA. This is the topic outline. You will be introduced on what is ANOVA, and then you will learn about one-way ANOVA, completely randomized design. So previously, we have considered cases with two population parameters only. So you can refer from chapter 6. So when we are dealing with two sample inference, we are actually dealing with a special case of one factor problem with two levels. For example, if we want to compare different brands of multivitamins, okay, we have brand A and brand B. So we need two samples from brand A and another sample is from brand B. So in this case, the factor is the multivitamins. So multivitamins is, we call it as factor, where this factor have two levels, which is brand A and brand B. So level we denote is as K. So here we have K equals to 2. So suppose we need to compare 4 brands of multivitamins. So here this is our factor. Given that this factor has 4 levels, given as brand A, brand B, brand C, and brand D. So we have 4 samples. Okay, the first one is from brand A, brand B, brand C, and brand D. So in an experiment, the factor, where we also call as independent variable, is an explanatory variable manipulated by the experimenter. Each factor has 2 or more levels, which is different values of the factor, and the combinations of factor levels are called treatments. Okay, so these are the definition in this ANOVA. So in the case where the number of levels is greater than 2, that is K is greater than 2, it is assumed that there are K samples from K populations. For example, previously that I show you where the number of levels from the multivitamins, we have 2 levels, which is from brand A and brand B. So which means that we have taken 2 samples from 2 populations. Okay, and then one very common procedure dealing with comparison of multiple population means, that is comparing more than 2 population mean, is the analysis of variance, which is ANOVA. Okay, so since we are dealing with only one factor, okay, for example, multivitamin, so it is referred as one-way ANOVA. So in our example previously is multivitamin, which contains only one factor. So the ANOVA can be extended to studies involving 2 factors. Okay, here we have multivitamins and dosage. So for this study, it involves a two-way analysis of variance. But for two-way will not be covered in our syllabus. So we just focus on the one-way ANOVA. One-way ANOVA test is used to test the equality of 3 or more means using sample variance. So if the comparison reveals a statistically significant difference, so we can conclude that the population means in one or more groups are different. So this is the hypothesis, given that the null hypothesis shows that all the population means are equal, given K is the number of level. Okay, and the alternative hypothesis will be written as mean I not equals to mean J for at least one ij, which means that at least one of the means are not equal. So these are the hypotheses that we need to write. Okay, once we want to solve the problem. So now let's go through the one. Previously, we used the F-test to compare two variances, okay, as shown in chapter 6. Okay, where this F-test is also can be used to compare three or more means. So for three groups, the F-test can show only whether a difference exists among the three means, but it cannot reveal where the difference lies. Okay, for example, is it the difference between x1, okay, mean from population 1 and mean from population 2, or mean from 1 and mean from 3, or mean from 2 and mean from 3. So if the F-test can indicate that there is a difference among the means, the other statistical tests are used to find where the difference exists. So the most commonly used tests are the Scheffé test and the Tukey test. However, these tests are not covered in our syllabus. So we just focus on finding whether there is a difference among the means or not. So even though you are comparing three or more means in this use of F-test, variances are used in the test instead of means. So with the F-test, two different estimates of the population variance are made. The first estimate, we call it as between group variance, and it involves finding the variance of the mean. And then the second estimate, the within group variance, where it is made by computing the variance using all the data and is not affected by differences in the means. So you will understand more while we do the example. So this is the formula for F-test for one-way ANOVA, which is F equals to variance between groups over variance within groups. So this is the formula for variance between groups, given it is the summation of the number of each sample multiplied with the mean from each sample minus with the grand mean square over k minus 1, given k is number of levels. And then the variance within group is given as the summation of the number of each sample minus 1 times with the variance from each sample divided by the summation of number of sample minus 1. And then we also have to know the degree of freedom for the F-test, given the degree of freedom for numerator is equals to k minus 1, and the degree of freedom for the denominator is equals to n minus k, where n is given as the sum of the sample size. So the sample size need not to be equal. Okay, we also can use the one-way ANOVA for the sample size that is not equal. So this is the results of the one-way analysis of variance, where we can summarize by placing them in an ANOVA summary table. So we start with the source. This is for the between group, within, which is also denoted as error, and this is for total. Okay, the next column is sum of square. Given sum of square, it shows the sum of square between the group, and then this is the sum of square within the group, and the total is taken from the sum of square from between and also from the within. And the degree of freedom, this one refers to k minus 1, and degree of freedom for within would be n minus k. And the mean square for the between would be equals to the sum of square for between divided by the degree of freedom for between. Okay, and we have the mean square for the within will be SSW over n minus k, where f is given as the mean square of between divided by mean square from the within group. So this is how to find the f-test value for the ANOVA. First of all, we need to find the mean and variance for each sample, and then we have to find the grand mean, which means that the total of the x divided by the number of size. And then step 3, we have to find the between group variance given as S square B, and then the find the within group variance, and the last one find the f-test value, where f-test value is find from the between group variance divided by within group variance. So the one-way ANOVA follows the regular steps of hypothesis testing procedure, where first of all you need to state the hypothesis. Okay, the H note, the alternative hypothesis, and then you find the critical value. Next is compute the f-test value, and from here you can make the decision whether to accept or reject H note, and then you can summarize the results. So now let's go through the first example. In the following biological experiment, 4 concentrations of a certain fertilizer are used to enhance the growth in centimeters of a certain type of cactus over time. So we have 6 cactus plants are used at each concentration. Okay, the following growth in each cactus is measured. So now we can see that we have one factor, which is concentration. And each factor, and for this factor we have 4 levels, which is 1, 2, 3 and 4, and these are the growth in centimeters for a certain type of cactus. Okay, here we have 1, 2, 3 and 4. So now perform the analysis of variance at the 0.05 level of significance, given this is the value for our alpha. Okay, now what we need to do is first is we state the hypothesis. So the null hypothesis would be, okay, here we have 4 levels, which is 1, 2, 3 and 4, which means that the level would be k equals to 4. So it will be all the means are equal, which means that we have mu1 equals to mu2 equals to mu3 equals to mu4. And for the alternative hypothesis, it would be mu not equals to mu for at least 1 j. So this will be our hypothesis. So now the next one is we can find the critical value. So to find the critical value, where we use the f-test, we need to know the alpha, and then we need to know the degree of freedom of the numerator, and also degree of freedom for the denominator. So alpha is given from the question, which is equals to 0.05, and then we need to know the degree of freedom from the numerator, given the formula for the degree of freedom of numerator is k minus 1. So here we know our k is equals to 4. It will be 4 minus 1 equals to 3. And then the degree of freedom of the denominator is given as n minus k, where n is the total sample, number of sample. So given here we have for each sample we have 1, 2, 3, 4, 5, 6. 6 times 4 is equals to 24. Minus with k is 4, so here we have 20. So this is the value for the degree of freedom for denominator. So therefore we can conclude that the critical value given alpha is 0.05. The degree of freedom for the numerator is equals to 3. And then the degree of freedom for the denominator is 20. So from the table, you will get the value which is 3.10. Okay, then next is we want to compute the test value. So first of all, let's find the mean and the variance for each sample. So let me just bring this to the... So you can just use your calculator to find the mean for each sample. So here is our mean for the first sample. For the first sample will be 8.97, and for the variance will be 0.561. Okay, this one is the value for the standard deviation. Okay, and then for the second sample, the mean would be equals to 8.2, and the standard deviation is equals to 0.329, and then the mean from the third sample would be 6.72, and the standard deviation is equals to 0.608, and the last one is the mean from this fourth sample, 6.08, and then the sample standard deviation is given as 0.431. Okay, so we have identified all the mean and the variance, and also the number of sample would be all equals to 6. 1, 2, 3, 4, 5, 6. Okay, now the next step is to find the grand mean. So here x bar gm, where we need to add all the values here, 8.2 plus 8.7 plus 9.4 up until 5.8, divide by the total number of data. Here we have 6 times 4, which is 24. And you will get the grand mean, which is equals to 7.49. Alright, then the next step is you need to find the between group variance. Where it is given as S square B. Given the formula for this one is the summation of Ni times with mean from each sample minus with the mean, the grand mean, square divided by k minus 1. So here we list out the first sample, which is N1, 6, okay, times with the mean from the first sample, which is 8.97, minus with the mean, the grand mean, which is 7.49 square. And then we go to the second sample. Plus with the number of sample from second sample, 8.2, minus with the grand mean square, and then plus with from the third sample, okay, number of sample, and then the mean from the third sample, which is 6.72, minus with the grand mean, and then square, and the last one for the fourth sample is 6 times with 6.08 minus with 7.49 square. So we divide all this with k minus 1. So we have k is 4 minus 1. And you get the answer, which is 10.551. Okay, so that is the value of S square B. Okay, next is you have to find the within group variance. So given the within group variance is S square W, which is equals to the summation of Ni minus 1 multiply with the variance for each sample divided by the summation of Ni minus 1. So here will be Ni for the first sample is 6 minus 1 times with the variance for the first sample, which is given as 0.561 square. Okay, since this is the value for the standard deviation, so you have to square this plus with 6 minus 1 multiply with the second sample, and then for the third sample 0.608 square, and for the fourth sample it will be 0.431 square. And then divide by the summation of Ni minus 1, so which means that for the first sample 6 minus 1 plus second sample 6 minus 1, third sample, and the fourth sample. So then you can get this, which is equals to 0.2446. Okay, now the last step for this one is finding the F test. Okay, the calculated F, which is F. Finding the F test, which is equals to the variance from the between, okay, and then from within, which is equals to 10.551 divided by 0.2446, which is equals to 43.1. 43.14. Okay, so you can see that our F test is greater than critical value, okay, which is 43.14 is greater than 3.1, so which means that we have to reject H note, which means that the different concentration of fertilizer give different effect on the growth of the cactus.